haven't really covered any actual material yet, but does anyone have any questions about anything before I get going? All right, so today we're going to start talking about units. And we'll talk about converting between similar, like units. And we'll talk about scientific notation, unit prefixes. And I think we should get through all that today. And then I'll be able to give you an assignment on this stuff. Before I do that, remember that there's no school on Monday. That's Martin Luther King Jr. Day. Okay, so I think the school is going to be locked. So, all right, so talking about units. Every measurement that we take in physics has units. In this class, all the units that we're going to deal with are going to be combinations of three basic types. So all the units in this class are made up of three basic types. Those are units of length, which could be, millimeters, inches, feet, so on, miles, light years, by the way. You should know this now that you're taking a physics class. A light year is a measurement of a distance. It's not a measurement of a time. If it was a measurement of a time, a year for light would be the same amount of time as a year for us, but it's how far light travels in a year. So remember that, and now you can insult people who bring it up wrong at cocktail parties or whatever. A lot of what we're trying to do here is to give you stuff you can make fun of people for, to make yourself feel superior. So the first type is length. The second basic type is time. Units of time are seconds, minutes, hours, days, years, so on. And then third is units of mass. And units of mass, I really can only come up with sort of two systems of measuring mass. There's grams, kilograms, milligrams, that stuff. And then in imperial units, you might think that mass is measured in pounds because your scale, bathroom scale, you flip it over and it has a little switch to go between kilograms and pounds. But actually, pounds is a measure of force. It's not a measure of mass. And we'll talk about the relationship between force and mass later. In imperial units, the actual measure of mass is called slugs. And it's not used very often, but that's what it is. But so, like the bathroom scale thing, so what a scale actually measures is the force that you apply to the scale. And so it accurately measures the force of pounds that you apply to the scale. Based on that, and based on the fact that they're assuming you use the scale on the surface of the Earth, they have a relationship between the weight, the mass of an object, and the force gravity applies to that object. And so that's why they convert between those two. But if you took a bathroom scale to the moon and measured yourself on it, it would tell you accurately how much force in pounds you applied to it, but it would be wildly off in its guess at what your mass is. Your mass is still what it is on Earth. We'll talk about all that later. The ones that are going to matter for us here, I didn't even put so the one that matters for us for length is going to be meters. The one we're going to use for time is seconds, and the ones we're going to use for mass is kilograms. And together, these form the SI system of units, which stands for, it's actually in French, but you can think of it as Standard International or the International System. But SI stands for some French thing that I'm not going to try to pronounce. So the red is the SI units. And that's what we're mostly going to convert everything to SI units to do calculations. These are not the only fundamental types of units. There is also charge. But in this class, we're not going to talk about electricity. And so everything that we're going to deal with is combinations of these. So like, for example, a unit of speed is meters per second. It's not any of these by itself, but it's combinations of these. And units of force are kilograms times meters divided by seconds squared, sort of this complicated combination of these three basic types. So the first thing we have to be able to do is unit conversions. And so what that is if you're given a length in feet, say, and to do the calculation, let's say you want to do it in SI units, you have to be able to express that number of feet in meters. And you're used to doing this, like 3 feet is how many inches, that kind of thing. But it can get more complicated when you combine these units into a single unit type. So the general steps, the general approach for doing a unit conversion so first of all, there's always a conversion there's always a conversion factor that comes from an equation of unit types, of units. So for example, if you're told that 1 mile is equal to 1,609.344 meters, this leads to two possible conversion factors. And the way you come up with these conversion factors is you know that if you divide something by itself, you get 1, right? If you divide 4 divided by 4 is equal to 1. Negative 6,000 divided by negative 6,000 is 1. And so if you know that 1 mile and 1,609.344 meters are the same thing, you can divide one by the other and know that fundamentally what you have is 1. And so we can write this as 1 mile over 1609.344 meters. And we can say that that's equal to 1. And that's also equal to 1609.344 meters divided by 1 mile. And so either one of these that you multiply to a value leaves the value the same. It's just something you can use to change the unit types, okay? Because what you're doing is multiplying by 1. Is anyone here running track this spring? Yeah, so here's what you should do. So 1609.344 meters is a mile. So if you run a 1600 meter, you should just keep sprinting for like 9.3 more meters. And then afterwards, tell your coach you were running the mile that day. It'll be really awesome. Okay. I don't know why they run 1600 meters in high school. It's very weird. Okay, so now let's say that okay, so that's all I want to say about that first step. The second step is start with a given quantity.
Oh, that was just like a example of the conversion factor.
Yeah, so that's how you get the conversion factors. That's right. And so the second step, I'm going to show how to use that conversion factor to change a unit type. So say you start with some given quantity. What you want to do is multiply it so you always have these two choices of conversion factors. You want to multiply by the conversion factor that cancels the unwanted units. Okay, so let me do an example. So let's say we want to know how many inches are there in 5 miles, given that 1 mile is equal to 63,360 inches. Okay, so we have this one equality. That gives us two possible conversion factors. The first one is 1 mile divided by 63,360 inches. That's equal to 1. And that's also equal to 63,360 inches divided by 1 mile. Okay, so now that we have the two possible conversion factors, the quantity that we want to change units for is 5 miles. Okay, so we're going to start with 5 miles. And I'm going to always put a division bar there so we're really clear about what's in the numerator and what's in the denominator. And now we have to think, which one of these two conversion factors do we have to multiply by to cancel the miles in the top? Those are the unwanted units. We're trying to get rid of those and replace them with inches. Well, miles are in the numerator, so we want miles in our conversion factor to be in the denominator. Do you see that? Any questions about that? And so we'll multiply this by 63,360 inches divided by 1 mile. Now you can always think of these units as like algebraic variables. They cancel the same way and multiply the same way. So now we can cancel the miles here with the miles here. And the units we have left are inches. So now all we have to do is multiply 5 times 63,360, divide by 1, and we get 316,800 inches. Any questions about that? You can also do it in multiple steps. Like maybe you don't know that there's 63,000 whatever inches in 1 mile. But let's say you know instead, so we want to convert 5 miles to inches, given that 1 foot is 12 inches. 1 mile is 5,280 feet. Okay, so this is going to be similar, but we're going to do it in 2 steps. We're first going to convert miles to feet, and then we're going to convert feet to inches. So I'll start with 5 miles, and I'll make it clear that it's in the numerator of our fraction. And then to convert from miles to feet, miles is what I want to cancel, so I want the conversion factor that has miles in the denominator. So I'm going to multiply by 5,280 feet over 1 mile. And if you want to keep track of where we are as you go, you can see that these cancel. And now we have feet as our unit. And now we want to go from feet to inches. Feet are in the numerator. So we want the conversion factor with feet in the denominator. So I'm going to multiply by 12 inches over 1 foot. Then the feet cancel, and the unit we're left with is inches. And if you go 5 times 5,280 times 12, you get the same thing that we got with the other approach, 316,800 inches. Anybody have any questions about that? By the way, I'm going to start using a shorthand that I guess I learned in high school, where instead of writing all the parentheses like this, I'm going to write the fraction bar, and then I'm just going to write vertical lines to indicate where the parentheses end. It's just like a little shorthand that I'm used to using. So the same thing as this written above would be 5 miles times 5,280 feet divided by 1 mile times 12 inches over 1 foot. So you can use that or not use that, but that's what I'm going to be writing. Okay, well now let's do a unit conversion where instead of just a single basic unit type, we have a combination of units. So let's say we want to convert 61 miles per hour, which you can think of as 61 miles per hour like this. And let's say we want to convert this to SI units. So SI units would have a unit of length of meters and a unit of time of seconds. And we're going to do it using that 1 mile is 1609.344 meters. And then 1 hour is, well, let's say that 1 hour is 60 minutes. And then 1 minute is 60 seconds. Okay, so I'm going to start with my given value. And I'm going to be really clear about what's in the numerator and what's in the denominator. So I'm going to start with 61 miles. And then hours are in the denominator. And it doesn't matter what order you do this because multiplying in any order is the same thing. I guess I'm going to first convert miles to meters. Okay, so do I want to multiply by the conversion factor 1 mile over 1609 meters or 1609 meters over 1 mile?
1609 over 1 minute.
That's right, because what we're trying to get rid of is the miles, so we need to be sure we cancel that. So that means putting 1 mile in the denominator here, and that means putting 1609.344 meters in the numerator. So those cancel. And now that, we have units of meters, so that part's good, but now we have to convert the hours to seconds. And I'm going to do that in 2 steps. I'm first going to go hours to minutes, and then I'm going to go minutes to seconds. Okay, so 1 hour to get this hour switched over to minutes. Now, in order to convert this hours that's in the denominator, in order to cancel that, we need to have the hours of our conversion factor, this time in the numerator, okay? So I'm going to put 1 hour in the numerator and 60 minutes in the denominator. And you can see that cancels this with this. And the units now are minutes. And now we want to convert this minutes to seconds. So again, I'm going to put minutes in the numerator in order to cancel that. So I have 1 minute is equal to 60 seconds. So that cancels that. Now the only units that are left are meters in the numerator and seconds in the denominator. So now it's just a matter of multiplying and dividing out these numbers. 61 times 1609 divided by 60 again. And you get about 27.2 0.26 meters per second. Anybody have any questions about that? Okay, so let's keep just sort of, we're kind of going steadily more complicated versions of this. This is really the last step, the last bit of difficulty you could have. So let's say that we want to express 38,640 yards per minute squared in units of meters per second squared. And we want to do it using that 1 yard is equal to 3 feet. 1 meter is 3.281 feet. And 1 minute is 60 seconds. Okay, so we're going to start with 38,640 yards per minute squared. And whenever you see a unit with an exponent like this, I think the best way to think about it is to think of it as yards per, in this case, minutes times minutes. Okay, so I'm going to expand it out. And that's, if you do that, it'll keep you from making a mistake, which is just converting the minutes once. Okay, it'll make you see that you have to use that minutes to seconds conversion 2 different times. Okay, so I'm going to start with, here's my fraction bar, and I'm going to start with 38,640 yards divided by minutes times minutes. And I guess first I'll go from yards to meters. In order to do that with the conversions that I have to go from yards to feet and then feet to meters. So to go from yards to feet, I'll put 1 yard in the denominator to cancel that one out. 3 feet in the numerator. Those cancel, and what you have left is feet. And now I'm going to go from feet to meters. So in the conversion factor, I need 3.281 feet in the denominator and 1 meter in the numerator. And so now our length units are meters, which is what we want. And now we have to convert the minutes to seconds. Okay, so the minutes are in the denominator. So our conversion factor has to have it in the numerator to cancel it. So I'll go 1 minute over 60 seconds. And you can see that that cancels one of those. And so we have seconds down there. But this isn't done yet. We still have this second minute that we have to cancel. And so we have to do this step one more time. So I'll go, Again, 1 minute in the numerator, 60 seconds in the denominator. Cancel, cancel, seconds. And now the only units that aren't canceled out are meters on top, seconds times seconds on the bottom. And so now you can just multiply this all out. 38,640 times 3 divided by 3.281. Yes? I'm sorry? Yeah, it is. That's right. And yeah, so if you multiply these all out, divide by all of these, you get 9.81 meters per second squared. Yep. Does anyone, I mean, I made it work out to this number for a reason. Does anyone know the significance of that number? We're going to see it all the time. Yeah, that is for something that's in free fall, and it doesn't matter what object it is, an object in free fall has that acceleration down. So that is the units, the SI units of acceleration. Air resistance kind of messes that up a little bit. It depends on the objects. So if you have someone in a parachute in free fall, their acceleration is a lot less than that. But that's just because of the interaction of the parachute and the air. But if you had a marble and you dropped it beside a pig, they would both fall with this acceleration. Yeah.
So then it's just the acceleration for gravity in a vacuum?
In a vacuum, yes. Or we'll talk a lot about this, yes, but that if you're in a vacuum, that's exactly the acceleration that you get for any objects, parachutes, feathers, anything, helicopters. Don't try to fly a helicopter in a vacuum. Any other questions? Okay, let me give you one to work through. So let's say I'm telling you, this is true. The density of steel, there are different types of steel with different compositions and stuff. It's just slightly different mixtures. But the density of steel is always right around 7,000 kilograms per cubic meter. What's the density of steel in slugs per, what do I have here? Cubic foot, given that one slug is 14.59 kilograms and 1 meter is 3.281 feet. Okay, so I'll pause the video and take a few minutes and see if you can work through this, okay? Kilograms in the numerator. And in the denominator, I'm going to write it as meters times meters times meters. And I'll first go from kilograms to slugs. So we have 14.59 kilograms in the denominator and 1 slug in the numerator. So those cancel. And now meters to feet, we have 1 meter is equal to 3.281 feet. And then we have to do it 2 more times. 1 meter is equal to 3.281 feet. One more time. 1 meter is equal to 3.281 feet. And now just divide out the numbers. Let's see. I don't have a calculator here. Anybody want to tell me what you got for this?
13.58.
13 point, did anyone else get that?
Yeah.
Okay, good. 13.58 slugs per cubic foot. Anybody have any questions about that? Okay, so that's really all there is to unit conversion. The next thing we have to talk about is scientific notation. And the idea of scientific notation is that any number can be expressed as plus or minus one non-zero digit and then a decimal point and then a decimal all times 10 to some integer power. And that integer can be positive or negative. So if that integer is negative, that's how you get numbers with an absolute value smaller than 1. And if that integer exponent is positive, that's how you get numbers that are with an absolute value bigger than 10. Okay, so like for example, the number negative 3,481.9 can be written as negative 3.4819 times 10 to the third. 10 to the third is 1,000, and so 1,000 times this clearly gives you this. And going the other way, 0.0087 is equal to 8.7 times 10 to the negative third. Ten to the negative third is 0.001. So, this is 0.001 times 8.7. So notice that if the absolute value of the number is greater than 10, then the exponent is positive. And if the absolute value is less than 1, then the exponent is negative. What if the absolute value is between 1 and 10? What's the exponent? 0.
A 0.
Yeah. Remember that anything to the power of 0 is 1. Okay, so in order to use scientific notation, you really just need 2 skills. You need to be able to go from a standard number to a scientific notation number. And the second one is you need to be able to go from a scientific notation representation to a standard number. And so I'll just give it to you in 2 steps. If you have your own way that works for you, feel free to use it. I don't care about using this method, but I'm going to give you a way that works if you haven't done this before. This isn't something we're going to emphasize a ton in this class, but you will have at least one assignment where you have to do it. Okay, so you need 2 skills for this. So the first one is to go from a standard notation to scientific notation. I'm going to write this down and then I'll just sort of describe how I do it when I think about it. As I do this, my example is going to be the number negative 541.6. Okay, so the first step, A, is to count the number of places left or right and sorry, squeeze this in here to your notes. Let's call this number of places capital N. So we're going to count the number of places capital N, left or right, that you have to move the decimal point to get one leading digit. That's the one non-zero digit before the decimal place. Okay, so what about with our example of negative 541? We would have to move the decimal point 2 places to the left. So n is equal to 2, and we're moving to the left. And then second, if you moved left, then it's going to be times 10 to the n. And if you moved right, it's going to be times 10 to the negative n. So with our example, once you move it over, that decimal point over, you have negative 5.416, and you're multiplying it by 10 to, we moved left, so it's going to be positive, the positive 2. Okay? Now, let me describe how I do it in my head, and if this makes sense, you can do it this way, and if it doesn't, you can just follow these steps. But I think I want to keep the actual number the same, okay? And so if I want to keep the overall number at 541, and I'm setting it equal to a number times another number, you know, this is a number, this is a number. Well, I made that first number get smaller, okay? So I have to make that second number get bigger in order for them to match up. You know, if I want to keep it at the value of 541, and I'm making the 541 smaller, I have to multiply it by something bigger to not change the overall value. And that's how I know that the exponent is positive. Okay. Let me do another example. So let's say our number is 0.000106. Okay. Well, I know I have to move the decimal point 1, 2, 3, 4 spots. By changing the number from 0.000106 to just 1.06, I'm making that number bigger. So I have to multiply it by something smaller than 1 in order to, and so I know that it has to be 1.06 times 10 to something smaller than 1. And that's how I know that it's a negative exponent. Okay, the other skill we need is to be able to go from scientific notation to standard notation. And the example I'm going to use here is 6.52 times 10 to the minus 4th. So I am going to say that so the first step is the absolute value of the exponent is what I'm going to call capital N. So in this example, my N is 4. And that's just telling me how many places I'm going to move the decimal point. And then if the exponent was positive, I'm going to move the decimal point n places to the right. And on the other hand, if the exponent is negative, I'm going to move the decimal point n places to the left. Okay. So in this example, this was negative, n was equal to 4, so I know I'm going to move the decimal point n places to the left. Okay, so I'll write this out as, what do we have, 6, 5, 2. And then, you know, you can think of there being like infinitely many zeros on both sides. And you're starting with the decimal point here. We're moving it 4 places to the left. So 1, 2, 3, 4. And so that's the answer. And then you can get rid of all the other ones. When I do it in my head, I guess I just think, I mean, I guess this kind of is how I do it, but I think, like I know if I'm multiplying by something that's smaller than, if I'm multiplying by a negative, I'm multiplying by a number smaller than 1. So I know I have to make this number smaller. And if I'm multiplying by something where this is positive, I know I'm multiplying by something bigger than 1. So I know I have to make this number bigger. Anybody have any questions about that? Yes.
Do you care about significant?
Oh yeah, good question. I do not care at all about significant figures. So you can round things sort of however you see fit. Because I know you've had that stuff a lot in chemistry, or you will have that stuff a lot in chemistry. So it just doesn't, it's not a concern of mine. But an interesting thing about scientific notation is, like, look at this number. Where did I start with? Look at this number 0.000106. And if someone asked you to tell them how many significant figures there were in that number, you'd have to remember all these rules that you learned, and they're kind of tricky, you know? I mean, until you sort of internalize what it means, the rules are kind of a pain to try to remember. Like, okay, do zeros count? Well, it depends. Zeros after the number don't count unless they're in a decimal, and then they do count. Zeros before the number, I guess they don't count if it's in a decimal. So it can be a little tricky if you're looking at a standard number. But if someone gives you a number in scientific notation and asks how many significant figures there are, the answer is just right there in front of you. Every number before the multiplication sign is significant. And that's just the end of it. So 1.06 times 10 to the minus 4 has 3 significant figures. 5.416 times 10 to the second has 4 significant figures. Okay, but I don't care about that in this class. Any other questions? All right, so the last thing that we need to talk about today is unit prefixes. And these are things like, I'm just going to give you sort of the 5 that come up the most. But you can look up all the other ones, and there's kind of unlimited ones. Micro, which is represented with the Greek letter mu. You can always remember what mu is because it's spelled mu, and it looks kind of halfway between an M and a U. That has the meaning 10 to the minus 6. Let's think of it as, so micro always means times something. So these prefixes always mean times something. So micro means times 10 to the minus 6. The next one is milli. That's represented with a lowercase m. And that means times 10 to the minus 3rd. The next one is centi. That's represented with a lowercase c, and that means times 10 to the minus 2. And then there's kilo. That's represented with a lowercase k, and that means times 10 to the positive 3rd. And then mega is a capital M, and that means times 10 to the 6th. And again, there's kind of two things that you ever need to do. You need to be able to go from something with a prefix to something without a prefix, and you need to go the other direction, something without to something with. So again, you need two skills. So the first one is going from something with a prefix to something with no prefix. And this one is immediate. The other one you have to think about for a second, but this one is just super quick and easy. All you do is replace the prefix with its mathematical meaning. Okay, so let me show you what I mean. So if you are starting with 50 kilometers and you want to express that in meters, all you do is where that kilo is, just stick in its meaning times 10 to the third, and then you're done. So 50 times 10 to the third meters. If you're going the other direction, so if you're going from no prefix to a prefix, you have to do it like a unit conversion. Where the conversion factor comes from the definition of the prefix. Okay, so as an example, let's say we want to go, we have 100 grams and we want to express that in micrograms. So what we're going to do is we're going to say 1 microgram. From the definition of micro, this is equal to 1 times 10 to the minus 6 grams. Okay, and that gives us our conversion factor. And now we can just do it as a conversion. So we have 100 grams. We want grams in the denominator to cancel this one. The grams cancel, and we get, this is equal to 100 times, this is an exponent rules thing. If you divide by 10 to the minus 6, that's the same as multiplying by 10 to the 6. So this is 100 times 10 to the 6 micrograms. Now you could go, so I'm going to make this 2 spots smaller. to put it in real scientific notation. That means I have to make this one 2 bigger, and so like that. Okay, what if you're going from some prefix to some other prefix? You're going from like megameters to millimeters. Well, you can just do it in these 2 steps. Just go from your starting prefix to no prefix, and then go back to the prefix you want. Okay, so you can always, in 2 steps, you can always go from any prefix to any other prefix. Any questions about that? Okay, well, let's stop there, and I'll give you an assignment with this stuff on it for, you have a full week till the next class, I guess. So,
Thank you.
yes, bye.